example 2b, we're going to practice evaluating a little bit more. Two problems here, the log base 16 of 64 I want to evaluate, and also the log base 25 of 1 over 125. So if you look back at example 2a, I started off with all of these expressions equal to x here, equal to x, equal to x. Well, I didn't write the equal to x in here, but that's really still what I'm trying to find. Okay, so we can always add that in. Anytime that we're evaluating, it's really like we're trying to find x here. All right, so first problem, log base 16 of 64 equals x. Let's write in exponential form. This really means 16 to the x power equals 64. Well, from here, 16 to the first power is 16, 16 to the second power is way higher than 64. So I don't have a whole number for x. But let's think for a second. I could rewrite 16 as 4 squared. Oh, and I could rewrite 64 as 4 to a power also. So 16 is 4 squared to the x, and 64 is 4 cubed. So then 4 squared to the x power really means 4 to the 2x equals 4 cubed. These exponents have to equal each other then. So 2x equals 3, and then we divide both sides by 2x equals 3 halves. Okay, and then our second problem, the log base 25 of 1 over 125. Let's start off exponential form. 25 is my base, so 25 to the x power equals 1 over 125. Now hopefully you recognize pretty quickly that 25 is 5 to a power, and 125 is 5 to the third power. Okay, so that means 1 over 125 is really 5 to the negative third. The negative exponent makes it 1 over, and then 25 is 5 squared to the x. So from here, 5 squared to the x power, we multiply our exponents together. We get 5 to the 2x equals 5 to the negative third. And now those exponents have to equal each other. 2x has to equal negative 3. So x equals negative 3 over 2. Our answer is very similar to that first part in example 2b. But hopefully that helps us seeing a couple more examples.